All right, what's up? Welcome back. We are doing episode 11 now. I think this is the fifth recording of this at this point. Sorry for the delay and everything, but I don't know, for some reason this recording has been a bit of a struggle. It's going to be a long episode, so brace yourselves. I think it's going to be like 40 minutes long. At least that's how long the recordings have been. And I think the microphone is working properly, so without further ado, let's get into it. Today, we are going to be dealing with game states as well as a new command pattern. So, we talked a little bit about the command pattern in the system episode. It's kind of what the basis of design for systems were. We're going to be utilizing that again, except we're going to go a more traditional path where command patterns usually run is they run like queues. You call them once and then they exit the queue until they're run again in the future. Systems are kind of run concurrently until you remove them or just completely delete the vector which they are a part of. So we'll be doing over that. We're also going to implement a game state. So game states are kind of what we have going in the main file right now. We have like a game entity, and then everything is created and attached to that game entity. And we're going to replace that game entity with a bunch of different sub entities below it, and those are going to be game states. And we're going to attach each of these entities that we created in the main file into their own separate classes, so that they're more mobile. You know, say we have, like currently, if you look at it right now, we kind of have like a grassy scenery with a player kind of walking around in it. So we're going to continue that, and we're going to create that as its own game state. That's going to be the game state overworld. But if we want to like attach a player entity to a different game state, say like the player enters a house or whatever, a dungeon, we want to be able to attach that player to that game state as opposed to only towards the overworld game state. I don't know if that makes any sense, but it will in a bit, especially once we go dig deeper into the project and how that's going to work out and look like. So pretty much we're just going to be transferring this 350 lines of code into their own separate files, and everything's going to look a lot cleaner and a lot more mobile. So without further ado, let's just get right into it. Let me close that out. Zoom in a little bit. We're going to be creating a new filter today. It's going to be our command filter. And you can guess what we're going to be doing here. It's going to be a new item. That item is going to be the basis for our command pattern. I guess it's also going to be a component. So call it component command. We're going to need two different includes here. One is going to be our obligatory component.h, and then the next is going to be entity.h. So what we're going to be using entity.h for is that's going to be our game states are all going to be like stored inside of an entity, kind of like pretty much everything in our project at the moment. So we will, whenever we call execute on our command, we want to be able to make sure it's utilizing whatever game state it's in to create that entity, or we could have different commands in the future as well, these one and done sort of objects. So this is going to be called class I command, extending our I component here. It's public, and then we're going to have virtual void execute, and we're going to have inside of it our game state call. So this might not make sense at the moment, like why we exactly need to have access to this entity game state, but if you go to like our main file right now, like just with our player, we're kind of setting up or utilizing a bunch of different objects that are related to that game state, i.e. like camera position, the controller that we're using, among others, like the materials that we're grabbing our player from, that's going to be changing based off of like what assets we're using in that area. So like a player house is going to be loaded in with a bunch of different, it's going to have different tiles and furniture compared to what the overworld is going to look like. So we want to make sure those materials line up as well. Yeah. So pretty simple stuff. We're going to go ahead and create a new filter here, and this is going to be our game objects. And we will be implementing the player game object. Now I'm not going to be implementing every single game object just because that's a lot of work and it's pretty tedious, but I will show you how I'm going to be setting up the player game object, as that should give you insights on how exactly I'm doing it for every single other object. It's just a lot of tedious, copy and pasting for the rest of it. And I'll go through each one just in case you want to look at it. You want some, more help maybe. But let's see, how do we call this? Player game object. Player. This is going to be including component command, namespace component, namespace command, and then, oh, we have a third namespace, that's right. Namespace game object. Class player, extending our I command. All right, so this is the skeleton of our player game object. But as I said before, we're going to need access to a bunch of different stuff. So we can't really quite set this up yet until we kind of get a feel of what the GameState entity is going to really look like. So before I dig further into our player game object, I think the direction I'm going to go is first create a new filter called GameState. And this is going to be a component. It's going to be a component GameState. And we'll just leave it as one word. I think that's fine. Component.h. So if we can just think of like a few things that GameState is really going to be doing, if we notice like how exactly, or we think about like how GameState's really going to run, there's like a few different options. One is, well, what happens when we switch to a GameState? We're going to first need to leave behind all the game objects from the previous GameState. And eventually we'll also have to save like positions of players, like where they're going back to. Say we warp to a house, we want to make sure we warp back to a proper location. But that sort of logic is going to come a little bit later. It's probably going to be using JSON as well as a mix of like component classes holding JSON objects that are stored hard inside of our project, as well as pretty softly during runtime. But that sort of stuff, that more complicated aspect, is really going to come later. For now, we're just going to be dealing with like a knitting and creating our game objects inside of our GameState. So, for instance, we're going to emit a remove function. For now, I think GameState is going to be abstract, so I'm going to call it a GameState for abstract GameState. And then, because we are going to be implementing some functions here, it's not going to be entirely interfaceable. So we'll have public here. We're going to have, do we want a protected variable for the game? I don't think so, but we will have a virtual void create function. and that is going to be passing through entity star eGame. So this is going to be like our master entity. So I guess here we're also going to need a include for entity.h, and then a game state is going to have entity star eGame, and all we're going to be doing inside of this constructor is going to be calling create. So there we have it. Let's pick up some sort of message here. Introduction. Okay, whatever. I'll answer that later. Cool. Next bit that we're going to be doing is initting the game state. So these are actually creating the game objects here. What create is going to be doing is going to be setting up all of our different component variables, which are going to be our, if we go to our command, they're game objects. These, we're going to be setting up these components to create our game objects. So they're not going to be directly creating the game objects until we run the command execute. So this execute here is going to be creating the game objects inside of our game state class, and then so it's pretty much just going to be setting up the blueprints. That's what create's going to be doing. So to actually create the game objects, we're going to be using this function called init. And init is going to be equal to 0. And then the next function that we're going to be calling is run. So what run is going to be doing is actually going to be running our game state and pretty much interacting with all of our game objects. So this is where, player, all the different stuff is going to be taken care of, rendering, updating, etc., etc. So this is going to be changing dependent on what game state it is in. So if we have multiple different update systems, multiple different render systems, we can all kind of package them together in a run system. For the most part, a lot of run is going to be pretty similar across game state to game state, but I have some ideas, especially in combat, where it's going to be utilizing something a bit different in run that I hope you guys will appreciate later on into this series. But yeah, that's about do it. Let's go ahead and start implementing our first game state here. So this game state, our first game state that we're going to be implementing is the overworld. So component game state overworld. Let's include component game state. And then let's set up some namespaces. Namespace component. Namespace game state. And then this is going to be class overworld implementing public a game state. And then we have void create here, override eGame. And then we're going to be using the constructor from a game state, so we'll just go ahead and call that using a game state, and that should move our constructor for overworld to be, or like we'll be able to use the constructor from a game state in our overworld class. It's just kind of like a must, especially since we are setting up using this, we're passing through like a bunch of different variables. This is kind of necessary to create this sort of thing. So our constructor for create, pretty much all we're going to be doing is we're going to first off create our e overworld. So e overworld is going to be equal to eGame add ID child, and we'll just call this child overworld. and then a few different constructors that we're going to be dealing with. One being we're going to need the renderer. So we'll go ahead and include component renderer. So this is going to help for run. Another thing that we're missing from our project that we will need, if you remember from our main, we're kind of loading all of these, our render and update systems into vectors. But these are not actually components themselves. These are just raw data structures. So we're going to have to need to create a new vector here. We're just going to call this component system vectors. And this is going to need component system, and we'll also need our vector C++ construct as well. So this is going to be namespace component class system vector, and it's just going to extend public standard vector of component iSystem pointers, as well as it's going to extend our public iComponent so that we can add it to an entity. So there you have it. That's our system vectors. So we'll go ahead and implement those in our overworld now. So we're also going to include component system vector. As well, we're probably going to be just adding our controllers to our game state so that we have access to that. Eventually, our component controller is just going to be just added to our game so that we can access it from there. But right now we don't have multiple game states, so we can just add it to our game state for now and then move it later once we do deal with multiple game states. So component controller.h, so we'll also need anything else. I think that's about it. So let's go ahead and we'll need some private variables. So one, we're going to need to keep track of the renderer to help with run. So we'll do that here. Let's see, component renderer, and we'll just call this C renderer underscore since it's a private variable. And then we'll also need to keep track of all of our system vectors. So to do that, component system vector C update systems, and component system vector C render systems. And then pretty much everything else is going to be stored as a game object, camera, tile map, etc., which we'll need to set up in the create once we are actually finished with those functions. All we have right now is the game object player. But we will also need to keep track of all of our different game objects. So to do that, this is going to be useful in a init. So we'll go ahead and create a standard vector here of our different game objects. Particularly, we're going to need, let's just include component command player. So we're going to need component iCommand here, pointer of them. And we're just going to call this init commands, as they're going to be called in init. And we're just going to be executing with our game state. Which probably means we'll also need our entity here. So we'll need to also keep track of our entity overworld in a private game object. So we'll just do that here, e overworld underscore, get rid of this auto here, and we'll just do it like that. All right. So now that we have everything set up, let's go ahead and start creating these component system renderer, the C renderer, update systems, etc. in our overworld. So we'll go ahead and do that by C renderer underscore is going to be equal to dereferencing egame, or sorry, not egame, eOverworld, add ID component renderer. And inside of renderer, we have a few different things. We'll go ahead and utilize those here. Where's our renderer at? Here we go. We're going to need the standard vector of unsigned integers as well as a name. So I guess we'll call this renderer. And I guess we'll need our definition of max sprites as well to be moved from our main into our new file. So we'll just copy that over. There we go. Ah, I see. Yeah, this has to be pointer because we're not setting this up in our constructor. So it has to be nullable, unfortunately. So we'll have to deal with just pointers for now. Kind of forgot about that. Need a semicolon there. And let's set up the C update systems, pretty similar to what we've been doing. C update systems underscore. Copy paste that over. We're going to need system vector. And the only thing we're going to be adding, the only thing we're going to be adding here is we're going to call this update systems. And then we can just copy and paste this for render systems since it's pretty much the same thing. I don't know why Visual Studios does these like weird spacings, but I don't know. It's Microsoft for you. They just kind of do whatever the heck they want. The last bit that we're going to need, the controller. Because the controller is not set up here. I don't think we really need to set up a variable for the controller, but we do need to add it to the overworld. So we might as well do that here. So I, or eOverworld is equal, or not is equal, overworld underscore add ID component. Let me just copy and paste what we have here, actually. That'd be way easier. Where is our controller at? Where are you at, controller? I need to copy and paste you. Here we go. Just copy and paste this bit right there. I called it keyboard. I'm just going to call it controller, I think. And then that's fine, whatever. That pretty much does our knitting here. We need to set up the game objects later, so I guess we could put a to-do, set up game objects in our init commands, but we can actually just start setting up our other functions as well. So if you remember correctly, we have init to set up as well as our run. So let's go ahead and set up init now. Init requires nothing but this, I believe. So init, all init is going to be doing is for auto command, or com, we'll just call it com, in init commands. We're going to call com execute, and we're going to need to pass through our e overworld. And then for a void run, override, we will be doing a similar thing to what we set up in our main. So in fact, we'll just copy and paste what we did there. And that is this right here. So all this stuff is going to be moved over into our run. C renderer. This is a pointer now. In our render systems, we need a dereference there. Actually, no, we don't need a dereference. Honestly, I think that's fine. But this is called C update systems. This is a component now as opposed to just a raw vector. Oh, we do have to dereference it. Okay, I was right. So those are pointers to a vector. We're going to need to dereference that so we actually access the actual vector as opposed to the pointer to a vector. All right. So now our run is all finished. Our init is finished. Now we actually have to start dealing with our game object player. So just like what we've been doing in the past, we're copy and pasting a bunch of stuff. Let's go ahead and copy and paste more stuff. Let's go ahead and find our player. I believe it starts down there, all the way up to our player entity up here. Copy and paste that component game object or command player. And we'll need a bunch of different includes here. One is our rectangle. Let's see if Visual Studio is smart enough to actually help us out here. We've got rectangle. Let's see, camera draw. And it's just stopped helping us out here. Maybe if we save it, looks like it's now working. Animation, movement animation. All right, perfect. So now the only things we need to do is all these red squiggly lines we're going to have to get from our game state. And also we'll have to make sure this is also getting from our game state. So we'll go ahead and change this to GameState add ID child. We'll just call this player for now. And I guess this is ePlayer. All right. So first off, our source, we're going to have to define that somewhere. I think the main issue with source is it's used by our tile map as well as our player at the moment. So let's just go ahead and copy this in to our player for now. And then we're just going to call this player source. Even though it's exactly the same in tile map and player, we'll just define it twice just to make it easier on ourselves. Copy and paste that here. So the next bit, we're going to need the renderer, the camera position, and the controller keyboard. But we don't actually need to do that. We can just call it C controller. It's also going to be C controller. As in the future, maybe we want to change it to a different controller that's not the keyboard. A couple other things, the movement animation and the speed at which it moves will also need to get changed at some point. see, where do we have the speed? I think we define it in move. Why is that missing? Good question. Go to system, update, move. Float speed is at the end. Okay. See, controller, transform, 4.0F here. Okay. Let's just start including some stuff. So before we set up our player object, we're going to need a few include or a few different variables outside of that. A lot of these game objects, like the shader and flesh text, are going to be shader sprite. They're going to be in game objects that we haven't created yet, but we kind of know what exactly they're going to be looking like since we've already created them kind of in main. So for instance, like flesh text is going to be in our textures, which is going to be added to our, I guess we never, well, okay, this is rolled back. This was like rolled back from a different project of mine. Well, not the same project, but I did it different. I set it up a bit differently. As you can see, I'm deleting all the entities without actually naming them or adding them to like a singular entity, our game. So this is going to be called, I think, textures or texture. So to get this entity, it would be in the game state. It's going to be called texture. And then if we want the flesh texture, we go ahead and find the component in that texture entity called flesh. That's going to be able to get our flesh texture. So auto and C flesh text is going to be equal to the game state get child being texture, and the at or get component texture, and that texture name is going to be flesh. So now we have the flesh text all sorted out. The next bit that we will need will be on dereferencing this here. Is our sprite shader. So auto and C sprite. I call it shader sprite, that's fine. I guess in keeping with the naming conventions, it should be sprite shader, sprite shade. I always call it shader. Screw it. E game state get child. And this child is going to be shader, and then we'll get the component shader. It's going to be called sprite. And then we have the sprite shader all taken care of. So the next bit that we'll need is the renderer. And if you remember when we set up the game object, the game state overworld, we just added it directly as a component to the game state. So we'll go ahead and set it up thusly then. C renderer is equal to E game state get component, and that component being component renderer. There we go. The next bit, we're going to need the controller, also set up very similarly to the renderer. So auto and C controller is going to be equal to E game state get component I controller. and that ID is just going to be called controller. That looks good. That looks good. It looks like we're just missing the camera position. So auto and C cam position. It's going to be stored in a game object. So we will be needing to get child. And that child name is probably going to be just camera. And that camera is going to have a component called position. So component, position. Oh, whoops, let's add ID child. We want to just get child or get component. Position. And then we have the camera position. So the last bit that we'll need to set up is these render and update systems so we can push back vectors into them. So to do that, our final bit that we'll need, C update systems. Again, like renderer and controller, it's just as a component. So E GameState get component, and that component being update or just system vectors. System vector. And then I think it's update systems is what we called it in GameState. And then the same thing with render. And I guess we're missing an include here, so we'll need to fix that as well. There we go. Now we just have to let's just copy and paste this, make this a little bit quicker. All right. So now we have our game object player all situated, all worked out. So this is going to be the basis of like how we do pretty much every single game object. I mean, we're already at like 37 minutes into this, and we still have like several game objects to go over. So I'm not going to put you through the torture that I'm about to put myself through, which is copy and pasting each of these. You can either just look at the GitHub and just copy and paste what you see there, or you can kind of go through the similar process which I'm doing, which is just setting up each of these game objects individually, like so. But I will be right back. I'm just going to pause the recording and finish up this, and then we'll go over the main and get pretty much our final product, get our game state loaded up and have it run in the main. And hopefully we'll just have pretty much exactly what we had in the last episode. So without further ado, I'll be right back. All right, welcome back. Just to go over a few things that we did. For one, we set up these init commands in our Overworld. So if you haven't done that already, I would set this up right now, because otherwise none of the game objects are actually going to be executed properly, and you won't be able to run your game without these. So I just add ID components, I ID'd them, added shader, texture, camera, tile map, and player. Those being the main 5 game objects that we're setting up with our Overworld game state. And then these are the game objects I set up. We have camera here, pretty simple. It's like 2 lines of code, adding the ID, camera, and the position. We went over player already. I just copy and pasted everything that we had from the main file into here. The VS file name, FS file name. Eventually this will be a bit cleaned up, as well as we might have different shader files in the future, so we'll need to move this somewhere as well. But yeah, this is what we got set up here, as well as like using projection, ortho, all that sort of stuff might get moved around. Here's our texture file, copy and pasted directly from the main with like a few changes. Kind of pretty similar setup. And then tile map's probably the biggest undertaking here. I moved these, tile map source, cols, and rows, just changed source to tile map source just to get it done and over with. And then, so we just did a very similar thing to what we did with player. We added in grass text, the sprite shader, renderer, camera position, render systems, all from our GameState, and then utilize that to, create our tile map so we can actually render and look at our tiles when we're walking around in the main world. But that's kind of all we did. Now we have to set up the main, so the main.cpp. And this is kind of where the fun begins, because we get to delete a lot of stuff. So we can go ahead and delete all of this. I guess another thing that we could do, we could create a deconstructor for Overworld here. Where we clear our C update and render systems, C renderer, release, I think is what I called it. Actually, I should take care of that, because we're going to be deleting that game object, or just like the entire thing in general. So it should actually terminate that properly. We don't have to worry about that. Just kidding. But we can delete this. That's all gone now. We'll leave entities created and components created. I think that's fine. But this is the real fun stuff right here. We get to delete all this. So that's all gone. We get to delete all this. Gone too. And then like a lot of this stuff is gone. And all we now have to include is our component GameState Overworld. And then I think we're missing our entity component or entity game, so we'll have to create that here. So auto e-game equals new entity. And inside of our game, we will need to add our new game state. So we'll go ahead, add ID component game state overworld. Let's just call this overworld. And I think we will need to include our game. So e-game here. So it sets up properly. Sure. And then we will actually need to call this CGS overworld so that we can call the run and init functions properly. So there's that. So CGS overworld dot init. And then all we have to do up here, CGS overworld.run. And this is going to pretty much do the exact same thing that we were doing before, except now we've knocked off like 100 lines of code or whatnot. So it's a little bit more compact and a little bit more mobile, so we can actually utilize these functions in other game states and whatnot. I'm just going to remove this. All right, I think that about does it. Do I have anything else I want to talk about? I don't think so. I think we'll just go ahead and run. We've got build errors, component source to T1. Looks like update animation. So it looks like our player, that's coming from our player update animation. This is all wrong. So we got to figure out why that's wrong. Let me see here. It's source, then speed. So it looks like we just have these flipped. It might have run first try for you guys. I did roll back these so they're like a bit different in terms of like how they're set up and their constructors or whatnot. What we got now, we got some linking errors. Create external symbol. Interesting. You know, I was thinking about this anyways. We could just delete this. Move create to a public. And just create this as an interface. This is a pretty easy change here. We don't have to deal with that anymore. Move this over to here. I mean, this isn't perfect because we can create twice, which we don't really want to be doing. We only want to really be creating once, but hopefully we can manage that properly and it won't be a big deal. All right. So we got that. We have some runtime error. So I wonder what that is causing here. Looks like there is something that is not working properly. Don't know what that could be, but let's just run it again. Maybe it'll work. No, it doesn't. Okay. Oh, we got an actual error this time. That's good. Division by 0. So it looks like our animations are getting loaded in improperly. That makes sense. So our adding is not properly loading correctly. So we will go to our player. Check out our animations, see what we're doing here that is wrong. Component system update animate. That looks right. I don't know why that would be an issue. This pushes back the animations, which are 8 of, and then we have each of the values, yada yada. Idle is a rect, or a source rect, I guess. Initial array list of component source, sure. Looks to be all good. Don't know why that's causing an issue. Let me just pause and I'll debug this real quick, have it running, and then I'll kind of showcase what the error was. So I'll be right back. All right, so I got it working again. This is our finished product. We have the ability to have a game state now. The issue that I was having was in like an older version of my project, I had spaces instead of underscore for a lot of my different string IDs. I switched to underscores just because spaces are just generally not friendly with computers, especially when like file and ID management. I'd just rather have underscores. But I forgot about that. I forgot to change that, so that's kind of why it errored out there. But I was able to figure it out pretty quick, so that's nice. All right. That's going to do it for this episode. Thank you guys so much for watching. I think next episode we get to do a little bit more interesting stuff. We're going to be going over tile maps. I believe that's episode 12. It's tile maps. I guess we'll find out very shortly once I actually look at my notes. But thank you guys so much for watching. Thank you for the continued support. Sorry about being so late on this episode. Technical difficulties, life, whatever. Should have no excuse. These videos are not that hard to create. But I'll see you guys soon. Thank you guys again, and goodbye.